Hello, welcome to this webcast session. From my home office, I would like to talk about cellular Internet of Things in 5G era. I'm Xie Feng, Market Segment Manager for Wireless Communication. More and more Internet of Things applications need cellular technology as a wireless communication interface. At the planning phase of 5G, 3GPP introduced the famous three pillars for different use case scenarios: enhanced mobile broadband, ultra-reliable low-latency communication, and massive machine-type communication. With the rapid rollout of 5G, we can see the clear trends with different technology groups. For eMBB, the applications are more or less data handler. IoT and 5G new radio will play a most important role here. For critical missions, IoT V2X and new radio V2X are defined for automotive applications. New radio industrial Internet of Things technology will come soon also for industrial needs like machine control, robots, and so on. For massive sensing applications, narrowband IoT and LTE-M played already important role at the late time of 4G. With additional features, they will stay here also in 5G era. Now, let me show you how those technologies are developed in the different releases and their relationship. IoT, which was introduced since Release 8 many years ago, is still successful in the field for eMBB applications. 5G new radio was introduced from Release 15 by 3GPP and commercialized rapidly worldwide recently. In ultra-reliable low-latency communication area, IoT V2X was the first technology to serve the automotive applications. With Release 16, new radio V2X and new radio industrial IoT technology are introduced. In massive machine-type communication area, LTE-M and narrowband IoT are pretty successful in the field with Release 13. They will stay here as part of 5G technology in the future with advanced features. Here, I would like to show some details with the development of different technology groups. We start with narrowband IoT and LTE-M. It is clear those two technologies are serving the applications which need deep coverage and high density. Most cases, those devices are powered by battery and need over years of battery life. They are low cost, but still prefer to have additional features like positioning, mobility, and so on. In Release 14, both technology got features for performance improvement. Enhanced the transmission block size and HIQ improved the throughput. Positioning with different method improved the use cases. For narrowband IoT especially, several additional features are introduced to reduce the power consumption and enhance the battery life. One example is the additional class of device is defined. Those device is allowed to have maximum transmission power up to 14 dBm. Another feature is release assistance indicator. This feature can help the base station to release the device as soon as possible. With this, the power consumption will be reduced once more. With release 15, additional features are developed with a similar direction. Wake-up signal is one of them. The basic idea is to use a simple signal to trigger the device to wake up. To monitor such a signal on the device side will use less power than decode broadcast channel. The device receiver will consume less power. In release 16, a major task is to make sure the narrowband IoT and LTE-M technology can work with 5G together in one network. Connection with 5G core network and coexistence with new radio are important work items with release 16 in 3GPP. From Rohde Schwarz side, we provide all kinds of testing solutions to meet the whole ecosystem testing needs. CMW platform-based solutions, CMW 500, 290 are well accepted by the market. They are used for protocol R&D and protocol verification testing with additional software like Rohde Schwarz CMW cards. For RF conformance and also protocol conformance testing, which is required by GCF and PDCIB certification process, is also possible with one-box CMW 500 setup. For baseband RF testing, narrowband IoT and LTE-M functions are available for all the spectrum analyzer and signal generator portfolio. For system-level RF testing, CMW and its automation tool, CMW Run, are well developed since years. As we said, power consumption is an important testing task for narrowband IoT and LTE-M devices. We have several different testing solutions for power consumption analysis. For benchmark and monitoring testing, CMW Run and RTZVC as a power probe is a good selection. For unbound design level testing, oscilloscope RTO RTE with RTZVC power probe is another good solution. For system level testing, the latest power supply, NGL and NGM, is another good solution. If the testing is not only limited to protocol and RF, but also go to the level of IP level, cybersecurity checking, IP traffic analysis, then CMW provides also the functionality inside the box to provide IP security analysis too. After good design, mass production with quality is also important. CMW 100 is the most popular RF testing tool in the production line, not only in the module testing process, but also for the vertical applications. Now I would like to switch to enhance the mobile broadband area. 5G new radio will support the data handler Internet of Things devices with high throughput and immersion experience. We will see the journey of 5G radio for Internet of Things applications. With the 5G network rollout in the last period, many 5G new radio phones are introduced to the market. But it is clear the intention of 5G network is not only limited to replace the mobile phone only. Recently, we can see more and more beyond phone applications. Based on 5G modem, surveillance cameras are connected for smart city or smart factory usage. More and more laptops get also 5G modem for all these online services. Behind all those, modem vendors start to work on 5G modules. With release 17, additional features will be introduced to serve more Internet of Things applications with 5G new radio. NCIS, Network Controlled Interactive Service, will be the good feature for online gaming and also virtual reality usage for industrial use cases. Another important discussion within 3GPP is about 5G New Radio Lite. What is 5G New Radio Lite? Basically, there are several typical Internet of Things applications need a good balancing between throughput, cost, size of device, latency, and also battery life. Several examples. The surveillance camera needs limited downlink throughput but pretty high uplink throughput. The latency and reliability is not very critical for those cameras. Another example, industrial wireless sensor expected pretty high availability and a good battery life for years. The throughput of those sensors will be not very high, but the latency time could be a good feature for those applications. A wearable device expected not really high throughput and the battery life for days is also fine, but the size of those devices is pretty important for the final usage. To fulfill all those kind of requirements, 3GPP start to consider to modify or define an additional 5G New Radio Lite version spec to match those requirements. This is the basic idea of Release 17 5G New Radio Lite standard. This will help the industry get good balancing with the cost, size, and of course also coverage for those devices. What can we do for you in the test and measurement area for 5G New Radio? We considered two major challenges in your 5G New Radio test and measurement work. The first one, how to use the existing testing solutions which are invested in the last years. Those solutions are still important for the testing tasks of legacy technologies. The second, what kind of new test measurement techniques are required? How to combine them with the existing testing solution. With the 5G New Radio, a new area is about millimeter wave, which need OTA testing solution. This is already very clear for the industry. For FR1 sub-6 GHz, we introduce SAM-X as extension to SAM-W. This extension can upgrade your IoT advanced testing setup with 5G functionality in the R&D area. For conformance testing area, the system from Rohde Schwarz is also possible to get similar upgrade with SAM-X. For FR2 millimeter wave area, we introduced many OTA portfolio, include different chambers, CAD-R, antenna, sensors. Our goal is to be one-stop shop for whole testing setup. For production line, The SAM-W100 is upgradable for 5G new radio in FR1, and SAM-P-SAM-Q combination is released as a millimeter wave production line solution for RF testing in 5G new radio. Under the ultra-reliable low-latency communication topic, I will not talk about the automotive part, but more focus on the industrial area. In the industrial Internet of Things applications, low latency and secure and reliable are highly required. The usage could be control the machine, robots, and other automations. In this context, two important topics are heavily discussed in the last period. The first one is about the additional spectrum. As we know, the current cellular communication network are using licensed spectrum almost everywhere. Unlicensed spectrum, ISM band, is of course possible for some special usage, but those areas are already heavily occupied by Wi-Fi, Bluetooth, and so on. In USA, there is one special topic named CBRS, Citizen Broadband Radio Service. This is about one dedicated spectrum which can be shared with different operators or service provider by kind of a sharing method, a data bank, and so on. The most interesting part is following. In the last period, to dedicate support the industrial usage, several countries shared or announced a new policy that different owner can have their own spectrum with kind of local licensing method. Means those spectrum can be used only in one area by one owner, kind of renting from the government. In Germany, 3.7 gigahertz is possible with 100 megahertz bandwidth. In Japan, 1 millimeter wave area, so 28.2 gigahertz with 1.1 gigahertz bandwidth is also possible with a similar idea. The similar topic is also discussed and also possible now in UK. 3.8 gigahertz for 390 megahertz bandwidth, or indoor usage, you see another millimeter wave area at 24 to 26 gigahertz. Besides this new idea of a spectrum, non-public network became more and more possible, and this is also defined now in 3GPP standards. With the different combination of C-plan and U-plan setup, four proposals are defined. The first one is a totally isolated network, which can be used in the factory or other facilities, and this is isolated to the public network. A second one is to share the radio access network with the public network, but the non-public network still have his own C-plan and U-plan. The next sharing possibility is to share the radio access network between the non-public network and the public network, and also share the control plan. The last idea is to provide totally sharing both C-plan and U-plan between the non-public network and public network. To support the development of industrial Internet of Things applications, Rohde Schwarz is already involved at a very early stage with our test and measurement solutions. One example is about our testing solution for channel sounding. As the indoor environment of factory and industrial facilities are quite different than the normal RF channel for cellular communication. It makes sense to analyze and study the channel response in those areas. All the machines with many metal inside and also the storage in the factory, all those leads to totally different channel sounding response. With our broadband signal generator SMW and the spectrum analyzer FSW, plus the additional antennas from our partner, software from our partner, it is possible to analyze broadband channel response for both FR1 sub-6 GHz and also FR2 millimeter wave area. This solution is already used with many institutes, and the testing result is already applied to the standardization organization. With the further development of 5G, Internet of Things applications will be major topics in enhanced mobile broadband, ultra-reliable low-latency communication, and also massive machine-type communication use cases. As a test and measurement vendor, we will continue with our existing test solution for 5G. We will also extend our portfolio for new test and measurement techniques. With all this, we will work with you together to discover 5G for Internet of Things. Stay safe, be healthy. With this wish, I would like to close this short webcast session. Thank you very much.